All right. Number 3. This is a no calculator question. Let f be the function defined by f of x, which is equal to square root of x plus 1 from 0 to 3, 5 minus x from 3 to 5. And g of x is this other function, k times square root of x plus 1, so some constant times the square root, from 0 to 3, and mx plus 2 from 3 to 5. Again, I see it, this is a square root, this is linear. This is a square root, this is linear. Not that it's important, but shapes often help me to figure out what the graph will actually look like. An idea of this graph is simply, the graph is going to start off as a square root, but then at 3, it's going to turn into a line. If I know what this kind of line looks like, I actually know that it's going to be down like this. So what I can immediately tell is, for the purposes of this, it could be continuous, but it's definitely not going to be differentiable, just because I can see that there's going to be a sharp corner here. For this one, because k is unknown and m is unknown, I don't know what the slope of the line and the curve will be, so therefore I can't make any assumptions. Is f continuous at x equals 3? Justify your answer. This always goes back to the definition of continuity. And it's really easy as long as you remember, I care about 3 things. I care about the limit of f of x as x approaches 3 from the left. I care about the limit of f of x as x approaches 3 from the right. And I actually care about f of 3 itself. Now, some people are asking, why do we know you're using f and not g? Well, again, it's asking, is f continuous, not g? So g has no bearing in this problem. 3 from the left, we're using the square root function. Square root of 3 plus 1 equals square root of 4, 2. From the right, 5 minus x, 5 minus 3, which equals 2. And again, f of 3, it's defined at 3. We will have an answer. We're going to use the square root again. 3 plus 1 is 2. Since the limit of f of x as x approaches 3 equals f of positive 3, f is continuous at x equals 3. Part B, determine the concavity of f of x at x equals 2. Since it's only at x equals 2, I don't need this part. I only care about the square root of x plus 1. So what I can do is I can say this. F of x equals, and since I don't need both parts, I'm just going to say the square root of x plus 1 at x, it was between 0 and 3. So therefore, f prime of x equals something for the bottom part, but who cares about that? It's 1/2 x plus 1 to the negative 1/2 chain rule. Derivative of x is just 1, no big deal. And here's where, since I need the concavity, I'm talking second derivative. Negative 1/4 x plus 1 to the negative 3/2. From 0 to 3. Should be less than, not equal to. F double prime of 2 equals negative 1/4. 2 plus 1 is 3 to the negative 3/2 power. Well, the nice thing is at this level of math, we kind of assume you know certain rules about exponents. An exponent cannot make a number negative. If 3 is raised to some exponent, it's going to stay positive. So this answer is already less than 0. Since f double prime of 2 is less than 0, f is concave down at x equals 2. Done. Find p prime of 2 in terms of p of x, which is f times g of x. I really like these problems because there's a lot of easy points to be gathered. The first 2 easy points are, since p is a product of f and g, as long as I can show I know the product rule, I can actually get 2 points out of this problem. So I know p prime of x is equal to let's keep f the same, take the derivative of g, plus keep g the same, take the derivative of f. As long as I know I'm using the product rule and I'm using the product rule correctly, I can actually get 2 points right away from this. Now the next thing is plugging in 2. This is where a little bit of caution comes in, because I need to figure out all 4 of these values and I can't screw up any of them. So I need f of 2, I need f prime of 2, I need g of 2, I need g prime of 2. The easy ones are f of 2 and g of 2. All I have to do is plug them in. So I go back up here and I say, okay, I'm going to use this function for 2 and this function for 2. So it's going to be square root of 2 plus 1, which is just square root of 3. Square root of 3. And then I'm going to need this one, which is k times the square root of 3. Well, most people would panic at this point because they're thinking they're supposed to get a real answer, but remember, it says find p prime of 2 in terms of k, so there is going to be a k left in the answer. Okay, so I know those two. F prime of 2. So now I need to find the derivative of the square root of x plus 1. Well, I sort of did that earlier. That was just 1/2 times, and this is going to be 3 to the negative 1/2. Now, for the other answer, if you look carefully, this is just k times, and k is a constant. Well, since k is a constant, I'll actually get the same answer, but with a k in front. Now, before I plug this in, this would be a mess with all these exponents. I'm going to slowly take one piece at a time. F of 2 is square root of 3. G prime of 2 is this guy. Well, it's k over 2, because 1/2 times k is k over 2, except this 3 to the negative 1/2 just means the square root of 3 is on the bottom. And if you recognize that, it's just going to make the algebra so much easier. Next, g of 2, another easy one. K times square root of 3. F prime of 2, it's 1/2, but take a look at where that 3 is. That 3 is raised to the negative 1/2 power, so that means I'm going to do a square root of 3 on the bottom. Okay, some quick algebra. Square root of 3 on top, square root of 3 on the bottom. Lucky me, that cancels out. Same thing right here. So I'm left with k over 2 plus, well, let's take a look. It's another k over 2. Half of k plus half of k equals a whole k. So there's your answer, just k. Last part, D. If g is a differentiable function at x equals 3, what are the values of k and m? Again, being very clever here, I know if I have 2 variables and I am looking for both variables and it's telling me differentiable, I'm going to need a system with 2 equations. Well, differentiability is a big piece, but the other piece that comes for free with differentiability is continuity. And that continuity is going to be the other piece. So let's talk about continuity first. Continuity comes, and this is again at x equals 3, from limits as x approaches 3 of g of x from the left side and g of x at x approaches 3 from the right side. Now I don't have to prove differentiability. It says if g is differentiable, so I know it's continuous. I'm not proving anything. I'm just using the definition to help me. Well, all I have to do is plug in 3 into the left side and the right side of g of x. Well, I'm just going to write g of x over here so I don't forget what it was. It was k times the square root of x plus 1, obviously ending at 3. And the other one was, I did forget, mx plus 2. mx plus 2, starting from 3. So if I plug in 3 into the left side, I'll have k times the square root of 3 plus 1, which is really just 2k. And plug in 3 into the right side, which is mx plus 2, so that's 3m plus 2. Because I know it's continuous, I know that these two are equal to each other, so 2k equals 3m plus 2. That's important. Get a point for knowing that. All I did was establish one equation, because I knew it was continuous. But it also told me it was differentiable. So what I want is, what is g prime of x? Well, I know what g prime of x is. That would be 1/2 k times x plus 1 to the negative 1/2. And the bottom one is just m. So what's the limit of g prime of x as x approaches 3 from the left? Well, plug in 3 into k over 2 times 3 plus 1 to the negative 1/2. And that simplifies to, well, let's see, that's k over 2 times, this is going to be 1 over the square root of 4, so this is k over 4. Then I want the limit of g prime of x as x approaches 3 from the right. Well, there's nowhere to plug in 3, so that just means stick with the m. So my other equation is m equals k over 4. I use both of these two in a system. I'm going to leave 2k equals 3m plus 2. But the other one, I just don't like fractions, so I'm going to multiply the 4 over. I'm going to say k is equal to 4m. I'm going to leave u with the algebra here, but with a little bit of magic, we can see that m equals 2/5 and k equals 8/5. Pause the video if you need to see the algebra of that. You can see that there are my two answers. M equals 2/5 and k equals 8/5. I simply used substitution, where I substituted 4m into there to figure out what the values of m and k are.